Hello everyone. Today we're going to talk about graphing certain type of function. To be honest, this is the second time or maybe almost third time that I'm trying to make this video. The sound quality was not good in the last attempts, so hopefully this will be the last time. Okay, we're going to discuss first as a function f of x equal to absolute value of x with some coefficient in front, a times absolute value of x. This coefficient is a real number. It could be positive, negative. If it's zero, then you're just discussing a horizontal line at zero as a constant value. So we avoid zero. And our simplest case would be f of x equal to absolute value of x. That means the coefficient that we pick, a, was simply 1. So let's look at this function. F of x equal to absolute value of x. How do you graph functions? You always create a table, pick certain x and y x values, find the corresponding y values, and find those points and draw a curve or straight line through those. Pick certain values for x, -2, -1, 0, 1, and 2, and their corresponding y values. How do I find the y values? You always replace the x values into the function, you find the corresponding y value. For example, if you replace -2, what do you get is +2. F of -2 is absolute value of -2, which is +2. So I'll find the point -2 and 2. If you try -1, you'll get -1 and 1, and so on. All these points are possible. And then you have the graph of the function. How do you graph it? Find those points. Have the point 0, 0, 1, 1, 2, 2, -1, +1, -2, +2. And if you continue, you'll get 3, 3, 4, 4, and so on. You can draw this straight line going through these points. And what do you get is basically the graph of absolute value of x. So absolute value of x has this simple form of the V. It's a 45-degree angle line that goes through these points. It's not always 45, it depends on the coefficient, but in this case, for simple absolute value of x, you'll have this 45-degree angle line. And what's important is one specific point. This point here is what I call it as a vertex. It's not originally called vertex, but I'm going to call it vertex for absolute value of absolute value. It's a unique point. If you find that point, then it helps you to graph the function more precisely. Okay, so I'll find the vertex, and then based on a couple of points on the left and right, I can draw the graph easily. How do you find the vertex? Is if you have an absolute value, always set the inside equal to 0. And what that gives you is the x value of the vertex. This is very common. So if you find the x value of the vertex, how do you find the y value? Replace it in the function. For example, in this case, inside absolute value equal to 0 gives you x equal to 0. How do you find the y value? Replace 0 into the absolute value. You'll get to find y value. That will be the point 0 and 0. Here's the next example. Based on the absolute value of x plus 2, how do you find the vertex? Set inside equal to 0. Inside is x plus 2. So I set x plus 2 equal to 0, and I found x equal to -2 is the vertex. How do you find the y value? Replace -2 for x, f of -2. You'll get absolute value of -2 plus 2, which is 0. So I have the point -2 and 0. -2 and 0. That would be the vertex point. If you look at the graph, -2 and 0. And how do I graph it? I'll pick more points. I'll pick -1, 0, 1, 2, 3, and so on. I'll pick -3. Y value becomes 1. If you pick -1, y value is 1. This is good enough just because you know straight lines going through those points. But if you want it to be more precise, you can pick more points to graph this straight line. If I know that vertex point, then I know where to create the V shape. This V shape is not always upward. It depends on the coefficient of the absolute value. This coefficient up front, the A times absolute value of x. Capital A, I think that's what we used originally. A times absolute value of x. If this A is a positive number, then the V shape is upward. If this number outside is negative, then the V looks like downward. Here's in the next example. You'll have -3 times absolute value of x plus 5. First, find the vertex point. Vertex point happens at x equal to 0. Then how do you find the y value? Replace 0 into the function. I replaced 0 and I got 5. -3 times 0 plus 5 is going to give you. So this point is the vertex point. I'll find 0 and 5. This is 0 and 5 on the graph. So there are two choices. Either the graph will look like that or it looks downward. It would be one of these two cases. If you look at the coefficient is -3. Since it's negative, I expect it downward to v. But I expect this case since the coefficient is negative. And how do you graph precisely? Pick a couple more x values. I picked -1 and 2. Found their corresponding y values by replacing -1 into the function and 2 into the function. I found out their y values. These are the corresponding y values. Draw a straight line going through those points. Actually, not that one. This is the other point, not this one. And this would be the other point. You can pick more points somewhere here and so on. 2 points is good enough to go create a straight line. That's why I stop at that point, but you can be more precise. Okay, so drawing absolute value is not anything complicated. It's just find that vertex point, and it's not called the vertex point in the book. I'm going to call it the vertex point, just because it has similarities with the quadratic function. Here about the next case is if you have a quadratic function in the form of ax squared plus b. If you have this function, ax squared plus b, we want to discuss these specific type where a and b are real numbers. And again, let's assume a is not 0, because that way it would be a constant line. Simple case would be x squared, where a is 1, b is 0. This would be x squared, the simple function x squared. If you graph this function, you always create a table, find x and y values till you get enough information about that function. Then you can maybe shorten up your steps, as what we did with absolute values. I picked certain x values, -2, -1, 0, 1, and 2. They found their y values by replacing -2 into x squared. I found 4, replacing -1, y becomes 1, 0, 1, and 4, and so on. And what would be your next step? Find those points. These are the points. I found all those points and draw a curve through those points. It's not going to be a straight line. It's going to be a curve. And now, if you compare it to the absolute value, there is a point specifically that if you find that point, then drawing the graph is much easier. So if I find this point, which I'm going to call it again the vertex. This is the vertex. Normally when they mention it, it's for the quadratic. So this is uniquely called the vertex. So the vertex happens to be at 0, and 0 in this case. But originally for the function ax squared plus b, the vertex always happens to be at 0 and b. Okay. And there is a general case that if you have a quadratic function like ax squared plus bx plus c, the vertex happens to be, x value happens to be at -b divided by 2a. In this case, we don't have b, so that's why the vertex always is at 0. I'm not going to get into the general case, but if you're interested, the vertex for quadratic ax squared plus b always happens to be at -b divided by 2a. You can try a couple of examples, just make sure that it fits this property. How do you find the y value? Is always you replace that x value into the function and it gives you the y value. So our main focus is only on this case, 0 and b. If you find the x value, always you can find the y value just by replacing. So for the ax squared plus b, the vertex happens to be at 0 and the y value is b. Okay, so now how do we find the vertex for this case? Let's look at the next example. Here is our next example, -2x squared minus 1. Again, vertex is at 0, x value of 0. How do I find the y value? Replace 0 into the function. -2 times 0 squared is 0 minus 1. That basically b is the y value. So I have the point 0 and -1. This is the point 0 and -1, and I know it's a vertex. So either the graph is upward or it's downward. And I need to decide which case. How do we decide? Similar to the absolute value. If the coefficient, ax squared plus b, if this coefficient of x squared, if this is a negative number, then you will have a downward graph. If it's positive, then you have an upward graph. In this example, it's -2, so it's going to be downward. You do not need to memorize. You can always draw this table, pick a couple of points. I picked 2 points beside the vertex. This is the vertex point. I picked 2 more points. I picked -2 and 1 and found their y values, got -9 and -3. So here is -2 and -9 and 1 and -3. And I drew a curve through those. But I made sure that the point 0 and -1 is the vertex. That means that point in this case turns out to be highest y value possible. That's called the maximum point. Okay, so it is important that when you graph these type of functions, you specifically find the vertex point just to be accurate. You can pick more points. You can pick a couple more points to make your graph look as precise as possible. Okay, here's one example that the vertex is not at 0. Just because if you look at the original case that we discussed is ax squared plus b. And we said the vertex happens to be at x equal to 0. This is the x coordinate of the vertex. I should say x coordinate. What if instead of ax squared plus b, it was some constant subtracted from the x value? So instead of x squared, it was x minus 1 squared. Then what happens, similar to the absolute value, that you replace the inside equal to 0. In this case, I replace the inside of the parentheses equal to 0. I'll replace x minus 1 equal to 0. And that gives me x equal to 1. That will be, maybe let me write that step. I'll set this guy equal to 0, and I'll get x equal to 1. This would be the x coordinate of the vertex. It's not necessary to know it through this process, but I'm going to mention it this way just so later on you're familiar with it. So x coordinate of the vertex in this case turns out to be 1. How do I find the y coordinate? Replace 1 into the function. 1 minus 1 squared plus 2. What do you get is 2. B is still supposed to be your y coordinate. Okay, so here, this is the vertex point. 1 and 2. And I picked 2 more points. I picked 0 and 2, replaced it in the function, and I got 2 more y values. And here is the vertex point. Is it upward or downward? Just because the coefficient outside was a positive number. It was positive 1. 1 times this parentheses squared. I know it's upward. And the 2 points that I found in the table tells me that my guess was correct, and it's upward. Here, this is how the graph looks like. Okay. So in general, if you have a times x minus b squared plus c, so look at this type of function. You have x minus b squared. Where does the vertex happens is where this highlighted section is 0, where x minus b is 0. That means where x is b. And how do I find the y value? Replace b into the function, and turns out this parentheses becomes 0. This whole thing becomes 0, and what the result is at the end is y must be c. So you will get b and c. This is the general form of a vertex for a quadratic, and this was an example of that. And one more function that we're going to focus on is the square root function. How does the square root function look like? The square root function looks like, again, you can draw a table, but before, in the other examples, we didn't really need to discuss the domain because we could pick any number that we want and replace it in the table. Here there is a restriction. When you're dealing with a square root, you're not allowed to replace negative number underneath the square root. So underneath the square root must be always positive or 0. So first you have to find out what is the domain. Domain turns out to be all the x's underneath the square root must be greater than or equal to 0. So therefore, the domain must be, if you write it in interval notation, it should be from 0 to positive infinity. Then when I pick points for the table, on the table for x and y, I'm only allowed to pick positive numbers or 0. I cannot go pick negative number because then I will get a complex value. It's not allowed to have complex values. If you pick 0, square root of 0 is 0. If you pick 1, square root of 1 is 1. If you pick 2, square root of 2 becomes root 2. It's not going to simplify. So I picked 4 and 9 instead because I know their square root is simply 2 and 3. And what you do is you find those points. Here are the points on the graph. And draw a curve through that. And one important thing that you should notice, the graph stops at 0, 0. It doesn't go to the left side. There is no continuation on the left side. Why not? Because the domain was restricted. You're not allowed to go to the negative section. We stopped at, the domain was from 0 to positive infinity. 0 to positive infinity, yes. So you're not allowed to go to the negative number. That's why the graph stopped there. And what is this important point that we're going to look at? It's this end point. This is what I'm going to call the vertex again. How do we find the vertex of the square root? Similar to the absolute value, similar to the quadratic. You set the inside of the square root equal to 0. That will give you the x-coordinate. So here, for our example, for this simple example, it was x equal to 0. In the next example, if you look at the next example, where is the vertex? It happens where this x plus 1 equals to 0 inside the square root. And if you do that, set x plus 1 equal to 0, you'll get x equals to negative 1. This must be the x-coordinate of the vertex. This is the x-coordinate of the vertex, x equal to negative 1. How do I find the y value? Replace negative 1 into the function. F at negative 1 is negative 1 plus 1 plus 2. So y value is 2. So I have the vertex point, negative 1 and 2. If I find the vertex, if I find the vertex, then I know the endpoint. This is the endpoint, negative 1 and 2. I know the graph will continue from this point. Either it goes to right or left, goes down or up. Doesn't really matter at this point because I can pick a couple of points. And I picked negative 1, 0, and 3. The other numbers gave me square roots. And before picking those numbers, it is important to do this. Figure out where the domain is. Otherwise, the numbers might give you a negative value underneath the square root. So I picked find the domain. How do you find the domain? Underneath the square root again must be greater than or equal to 0. Otherwise, it's undefined. The number that you will get is a negative number underneath the square root, and it will give you a complex value. Solve this inequality and you'll get the domain to be negative 1 to positive infinity. Negative 1 to positive infinity. Here is negative 1 to positive infinity. The graph should be in this section. It should not go below that negative 1. And as we mentioned, negative 1 and 2 is a vertex point. And either now the graph looks going upward or going downward. One of these two cases. And how do I find that exactly? This is where these points come in. Negative 1, 0, and 3. Negative 1, 0, and 3. These are the 3 points that I picked. And I got corresponding y values became 3 and 4. And I found those points, draw a curve through this. And now I have a graph for square root of x plus 1 plus 2. This is how the graph looks like. Okay, so finding the vertex point is important. Finding the domain is very important. And after that, just a couple of points to graph the function through those. Here's a maybe more complicated one. It's not any different, but it's going to be... let me, undo this. I wanted to get rid of these red circles. I can do this. Okay. Now what we have is negative square root of negative 2x minus 6. And I wanted to show you that the graph is not always increasing toward right. It could be decreasing and going toward left as well. There are 4 possibilities when you're dealing with square roots. It could look like either one of these cases. Okay, but there is always an important point. This end point is what we call it the vertex. So first you figure out what the vertex point is. How do you find the vertex? Set the inside the square root equal to 0. Negative 2x plus 6 equal to 0. X must be 3. So if x is 3, how do I find the y value? Find out the y value by finding f of 3. Is negative square root of negative 2 times 3 plus 6. Turns out to be 0. So the vertex happens to be a 3 and 0. Then find the domain. Where is the domain? Inside the square root must be greater than or equal to 0. Solve this inequality. Subtract 6, divide by negative 2. Make sure when you divide by a negative number, flip the inequality. So x must be less than or equal to 3. In interval notation, negative infinity to 3. It's not 3 to negative infinity. Negative infinity is smaller. So from negative infinity to 3. This is where the graph ends up. From negative infinity to 3. Sorry about that. Okay. And where is 3? This is 3. Where is the vertex? The vertex is at 3 and 0. This is 3 and 0. Vertex is at this point. So the graph stops at that point. And since we know the domain is on the left side, so the graph should be on the left side. How do I find the exact values? I pick a couple of points. I picked 2, 0, 1, negative 5 for x. If I put 2 into the function, you'll get negative root 2. It's not a number, it's a decimal number. That's why I ignored it. This is not a good choice. If I pick 0, I get square root of 6, negative square root of 6. Again, it's a decimal number. It's not really nice. But if you pick 1 and negative 5, then the corresponding y values are exact values. So maybe these are better choices. That's why I only use these two. I picked 1 and negative 2 and negative 5 and negative 4. It's just by trial to see where do I get some numbers that I can precisely find without the approximating. So now I have 3 points, draw a curve through those 3 points. Maybe this red line is already goes through those points. So this is 1 and negative 2. This is negative 5 and negative 4. Okay. So if you find the vertex and the domain, you should have almost enough information. This negative sign outside tells you if the graph is above or below the x-axis. This negative sign inside the coefficient of negative 2 tells you if the domain is on the right side or on the left side. These are hidden information in the equation given function, but I don't want you to memorize anything. Just go through the process of finding the vertex, picking a couple of points, and then graph the function. Okay, all that being said, now I'm going to discuss this topic of translation of a graph. Means you're given a function like f of x, and they ask you to graph a new function based on the given graph. So something like f of x plus a plus b. X plus a is inside value for the function. B is an outside constant. So adding a certain constant inside or outside makes an effect on the graph. What are the effects? If you add a constant a inside, it has an effect on the graph by doing a vertical or horizontal shift. What is that horizontal shift? It's going to be exactly the same amount of unit that you add or subtract inside, but in the opposite direction. That means if you add 2 inside, the graph shifts to the left 2 units. If you subtract 2 inside, the graph will shift 2 units to the right. How about if you make a change outside the function? If you add a 3 at the end, then the graph will shift up and down. And so it would be a vertical shift. So you'll have 3 units upward, or if it's minus 3, shift 3 units downward. So Normally changes inside the function are in opposite manner. So if you multiply a number inside, for example, and when you graph it, you should divide x values by 3. We'll discuss this again. But if you add a constant inside, you're going to shift it left and right. Depending on if that constant is positive, you go left. If it's negative, you go right. But if you make a change outside the function, then you move up or down. Here's an example just to discuss it through an example. Let's say f of x equals x minus 2 plus absolute value of x minus 2 plus 3. And you're given already the graph of f of x equals absolute value of x. You're given this graph. And how does it look like? It looks like this. This is 0, 0, 1, 1, negative 1, 1. This is the graph of absolute value of x. And you want to graph this x minus 2 plus 3, absolute value of x minus 2 plus 3. First, what does that minus 2 do is a change inside the function. So that is a horizontal shift. How many units? 2 units. In which direction? To the opposite direction, so to the right. And second, this plus 3. Those are the changes that they have made to the absolute value. That plus 3 is a vertical shift. How many units? 3 units. In which direction? Upward. It's not in the opposite direction. Outside, it's always the same direction. So 3 units up. So if I start from this graph, absolute value, and move every point, I move this point, 2 units to the right and 3 units up. Where do I end up is at 2, 1, 2, 3. I'll end up here. You move the next point, you'll move 1, 2, 1, 2, 3. I'll end up here, and so on. The next point, this point will end up there. And what do you get is exactly the same graph, but shifted 2 unit right, 3 unit everywhere. This point will end up here. That point will be here, and so on. I've moved every point 2 units right and 3 units up. And what happened to the vertex, by the way? Instead of being 0, 0, now we're at 2 and 3. This is the coordinate of the vertex. And now this green graph is exactly the graph of absolute value of f of x. F of x equal to absolute value of x minus 2 plus 3. So instead of drawing the table and stuff, I can simply, just by doing shift vertically and horizontally, I can graph the function. You can check to see if our vertex point is correct. If you remember, to find the vertex point, you find the x value by setting inside equal to 0. What you get is x equal to 2. How do you find the y value? Y is by calculating f of 2. You replace this x value into the function, you get the y value. So the value of 2 minus 2 plus 3, which is 3. So what is the point? It is 2 for x, 3 for y. Exactly this point that we have. Okay, and that shows that our idea is correct. Okay, here's the next example. What if the function was square root of x plus 2 minus 3? Again, you can go through the same process that we did already, but the translation helps a bit. Start with a simple graph of square root of x. This was square root of x. So if you know the square root of x, this origin was the vertex point. What does this plus 2 does inside? The plus 2, 1. Plus 2 is a horizontal shift, 2 units in the opposite direction, left. This minus 3, what does that do? Because the second step would be is a vertical shift. How many? 3 units. In which direction? Since it's negative, I go downward. Okay, so every point shifted 2 unit left, 3 unit down. The vertex point will come here. The next point will move here. That point will move here, and so on. All those points will move. What do I get is this graph. This is the graph of square root of x plus 2 minus 3. Again, you can check by finding this vertex point. And if you remember, to find the vertex point, you set the inside equal to 0. X becomes -2. Replace -2 in the function, you will get y equal to -3. And this is exactly the coordinate of this vertex point. So you do not need to go necessary to find the table. You can just simply, through this translation, you can find the graph. Okay, I'm gonna stop here and continue next topic.